Today we're going to do section 9.7 probability. So first let's look at example 1. Okay, example 1 says let's consider the probability of tossing a die. Those are those things with 6 sides where it has dots, number of dots 1 to 6, and you throw it and it pops out any number from 1 to 6. Now what is the probability of each one showing up? Well, being that there are 6 of them, and then for each one to show up would be 1 out of 6, and that is the answer. Okay, now that sounds obvious enough, but unfortunately probability gets rather confusing to me very quickly. Okay, but so let's look at the next page, on page 955, where we have considered the probability of an event is given by the number of elements in the event versus the number of elements in the sample space. What that means is, for example, let's look at example 2 to see what that means. It says we have a 6-sided number cube, okay, numbered 1 to 6. Find the probability of rolling an odd number. Well, out of the 6 numbers, half of them are odd, or should I say 3 of them are odd and 3 of them are even. So the number of elements is 3. I mean, in the event, what was E again? Event is E is 3, whereas the total number in the sample space is 6. So the probability then is equal to 3 divided by 6, or 1 over 2. The probability, the total probability at the most will be 1. Okay, 1 means a sure thing. That is the chance of tossing a die to get any number from 1 to 6, the probability is 1. Okay, and then the probability can also be 0. For example, if you want to toss a 7, there's no such thing, because the numbers are only on 1 to 6. So probabilities can go from 0 to 1. Okay, 0 is the no chance, and 1 is a full chance. So you're guaranteed to get it, and then every number in between. So that is example 2. So next, let's consider the concept of union of 2 things. The union is the union of 2 events. It means that the probability of either one thing happen or the other thing happen. Well, the union happens if either or both occurs. So the probability of the union is given by the probability of each event, okay, and then minus the probability of the intersection of those 2 events, because what happened is that if the 2 events have something in common, so then you're counting it twice. So you subtract the ones that are in both groups, and now that is to say that now I don't remember us ever explaining what is the union. Union is the combining of excuse me. Union is the combining of 2 sets, whereas the intersection was in common of 2 sets. Like this, we have the union symbol in 2 sets. Let's say you have a set A and a set B of stuff. They might be, let's see, what might that be? And then they might have something in common. An example would be, let's say that this is off the top of my head, I can't even think of anything that's 2 groups with some members in common. Okay. How about we call it this? This group will be called SpongeBob fans, okay, in this circle, the whole thing. And this group will call it Star Wars fans, okay? And then what's in the middle, those are the ones fans of both SpongeBob and Star Wars. And I'm one of those, right? So that is what's in the common. So that would be, so the entire, all the people in both groups will be called the union. So SB union SW would be everybody here, okay? Whereas SB intersect SW would be only these guys right here. That is what the symbols mean. So the people who are only the ones in the intersection, that is, that belong to both groups, is called the intersection. And this is union, is just you can be in either or both. Okay, then you are in this group. So this is a much bigger group than this one. So that is, okay, so that is just to explain the notation here. Now to demonstrate this concept, let's consider example 3 on page 956. We have where it says that there's a card that's drawn from a standard deck. Now a standard deck in math means 52 cards. Okay, we don't care about the other two. There are 2 more cards, but we don't care about those. At least in this problem. So a standard deck of 52 cards, which means we have 13 of each card, okay, from, yeah. Anyway, so that ace will be counted as 1 and then all the way to 13, I think. I haven't seen a deck of cards in years. So, but I believe that is correct. So the problem is, if we pick a card out of the random card out of a deck, now 52, find the probability of drawing a heart or a 7. So that is an or situation. So we have to use this formula right above it, where we saw just now, which is we have to, the probability of a heart or 7 is the probability of the heart plus probability of 7, and then minus a probability of heart and 7. Okay, so let's do that. What is to do that? What is the probability of heart? The probability of getting a heart, and so we'll call it pH. Okay, pH then equal to anyway, pH. I think every 4 card is a heart, right? So total number of hearts is 13 in any deck. So the pH will be equal to 13 over 52, which is or 1/4. That's the probability of a heart. Now the probability of a 7 would be 4 out of 52, because they are all numbers going from 1 to 13, 1 being the ace, and then 7 is, well, so there's 4 of them. There's 4 of everything. So then it equal to 4 over 52. That looks kind of faint. I think I'll get a better marker. All right. So then, and then next is so these 2 are fine. Next, we need to subtract out when we counted the number of hearts, in here are also the ones that are also the 7s also in here, right? So then when we count the 7s, some of them are hearts. In other words, there's something in here that is the number that is both heart and 7 are counted twice, once in here and once in here. So we need to subtract it out. So the probability of heart and 7, so P of heart and intersect and 7. I don't know if we should write it that way, but whatever. Is heart and 7 is there's only 1 card that's both heart and 7. So that's 1 over 52. So the total number then is equal to, according to the formula here, is equal to the first probability plus the second probability, that's 1/13, and then minus the last probability, which is being repeated, which is in both. So we subtract 1 of them out. That's the extra, okay, the repeat. So we subtract the repeat, and that equals to whatever. And let's figure out what it equals to. Let me find my calculator. I had it right here. All right, so let's let's do that. So first, we have 1/4 plus 1 over divided by 13, and then minus 1 divided by 52, that equals to 413 is what I got. And that sounds about right, I think. Let me check here. And the book says, yep, 413, so that is correct. Now, the next thing is, if we have events that's mutually exclusive, that just means mutually exclusive, that means they have nothing in common. That is, the two sets have nobody that's in common to each other, okay? Like, such as, for example, any two groups that can have nobody that has nothing, that has absolutely nothing in common, then they are called mutually exclusive events. In those cases, then you don't have to subtract anything, okay? Because what's in common is 0. So that's why you don't have to subtract it, because there's nothing to subtract. So next, let's look at example 4 on page 957. So, okay. It says a card is drawn from a standard deck, again 52 cards, and the probability of drawing a heart or a spade, well, those two are not, there's nothing in common about them, so we'll just count the heart and then count the spade. I think every 4 card is a heart, right? So it's the 1/4, and every 4 card is a spade, so another quarter. So together will be 1/2, and that is the answer of example 4. So let's move on to the next problem, is the complement rule. So sometimes we have the probability of something that is, the problem is presented such a way, then it's easier to just figure out what isn't it, and take 1 minus that amount. Now, as the best way to explain that is, let's look at the example here. Well, okay, anyway, so this is, what are we asking? Anyway, so the complement rule to calculate, I don't see that this is really a big improvement, but anyway, so let's look at example 5 on page 958, where we have 2 dices rolled. So we roll 2 dices, and then the probability that the sum of the numbers rolled is less than or equal to 3. And then the other, that's part A. Part B, we want to where the sum of the numbers rolled is greater than 3. Okay, so what are the so-called the brute force way of solving this problem is simply write out the whole thing in a chart, okay? And such a chart can be written out fairly quickly if you use the spreadsheet. So if you haven't learned how to use the spreadsheet, please look up some YouTube video or something and learn how to use the spreadsheet in a very basic way, such as drawing this chart. This chart can be done very quickly on a spreadsheet. Okay, you just type in 1, 1 and 1 2, and then pull it across, and it will get to 1 6, and then you will write down 2 1 and pull it down and go to 6 1. Then you pull it across, and all 36 numbers will show up. That sort of thing. Anyway, but anyway, so right now we have to figure out when the sum of the numbers rolled is less than or equal to 3. So when we look at this chart that's written down here, now then you can see, count quickly which ones are less than or equal to 3. There's only 3 of them, right? 1 1 1 2 and 2 1 is less than or equal to 3. Everything else is not. So then the answer to the first question is that there are 3 things that's 3 options or 3 combinations that's less than or equal to 3 out of a total of 6 by 6, which is 36 options. So the chance of rolling a sum of less than or equal to 3 is 3 over 36, which is 1/12. Now what's the probability of being greater than 3? That's the other option. Okay, so the total probability is 1. So if the first probability is 1/12, then the rest of it has to be 11/12, because it is either less than or equal to 3, or it has to be greater than 3. There's no other outcome. Okay, so then if we take 1 minus that, then we get 11/12, and that's all the rest of it. Or alternatively, you can count the rest of it if you want. So see all the rest of it are greater than 3, right? You can just count all of them. Or just, there's 3 here. We only have 3, so the rest of them will be like 33. It will be 33 over 36, and that gives the same answer as well. Okay, so that is, so far it seems okay, right? I mean, nothing is too terrible, although I think example 5 is somewhat terrible because we have to come up with this chart. I mean, this chart has a 6 by 6. I mean, what if you had a lot more than that? And what if your chart has 3 or 4 things being multiplied together? These only have 2 things multiplied together, so we can put it in a 2D chart. What if you have 3, 4, 5 things all multiplied together? That gets super confusing. But right now we're not going to do any of that, so we're still okay. So let's look at example 6, where we have to use counting theory. That is the NCR that we learned before, okay, in the previous section, how to count or choose, how to choose, okay, and the permutations with the NPR and NCR. I think mostly NCR, in order to do the next example. Now, so the best way to look at this is by let's look at this example here. Okay, and the example sounds innocent enough. It says a child is picking 5 toys from a bin that contains 3 rabbits, 3 bunnies, 5 dogs, and 6 bears. Okay, so then, and the child has to pick 5 toys. Now the question is, let's look at part 1. I mean part A. Okay, we have a child. We have select 5 toys. A child selects 5 toys from a toy bin containing 3 rabbits, 5 dogs, and 6 bears. So we need to choose 5. So part A says find the probability that the child chooses 5 bears. Okay, all bears. So to do that, we have to do this the NCR business. That is, which first count on the top, the probability is count the number of waves of choosing bears. There are 6 bears, so we need to choose 5. So then the total number of ways of choosing bears is C6, 5. And then on the bottom is the number of wave of choosing 5 toys out of all this stuff. How many things are there? That's 8 plus 6 is 14. So it's C14, choose 5 things. And then we divide it, and that is the probability. All right, so that let's do that. And okay, there is not much to do left here to do except to find the calculator. Here it is. Now to do the C65 over something, let me turn on the calculator. So we'll do 6 choose 5. So 6 choose 5 and divided by, what is that? 14 choose 5. That's 3 over 1001. And according to the book, that is correct. Okay, so that is so far so good. Okay, that's the chance. Whatever that number is, that's about 0.003, right? 3 out of 1,000, that's, yeah. And so that is 3 out of 1,000, well, whatever. Okay, a very small chance that 3 out of 1,000, that's 1 out of a few hundred. All right, now problem B is more complicated. Now we have, we're still choosing 5 toys, but the question is now we want 2, what's the chances of choosing 2 bears and 3 dogs? So then we have to follow the formula, which is like this. So 2 bears, we have a total, we do this, the C business again. 2 bears, how many bears are there? 6. So we choose C, will be choose 6 choose 2. Okay, that's for the bears. And then 3 dogs, did I say? Let's see, what am I looking at? Yeah, 2 bears, 3 dogs. There are 5 dogs, so we have we need to choose 5 choose 2 of dogs, and then divided by the same thing before, which is we're choosing things out of 14 5 out of 14 toys. And so we're going to pull that off, and then and that will give us the probability of choosing 2 bears and what? Didn't I say 3 dogs? Let's see. What do I have here? Let's see, 2 bears and 3 dogs. Yeah, that should be a 3 here. Okay, so that's better. We're doing the 2 bears, 3 dogs trick. Okay, try again. We are going to choose, let's see, so we have 6, choose 2, times 5, choose 3, and then divided by 14, choose 5. That's 75 over 1001. And let's see, that should be that. Okay, that's correct. So far so good. Okay, and then the last question is the probability that at least 2 dogs are chosen. So if it's at least 2 dogs are chosen, that means we can do the. I suppose we can do the complement rule, or maybe not. Let me think. All right, so part C, we're going to use the complement rule. We need to figure out how the probability that at least 2 dogs are chosen. So we're going to do it by calculating what's the probability of no dog and 1 dog is chosen, and then subtract 1 from it, and that will give us at least 2 dogs. Okay, so first we'll find the probability of 0 dogs. If 0 dogs are chosen, that would mean that so then there are 9 toys. So we the 5 toys will come from the toys that are not dogs. Okay, which there's a total of 9 of them. So then we have for 0 dog. So I'll write down 0D. Okay, for 0D, then the probability will be equal to choosing toys out of the 5 toys out of 9 things that are not dogs. So C9, 5. So we'll do 9 choose 5 and divided by the same denominator as before, 14 choose 5. And that will give us something. We'll write it. We're gonna. So let's figure out what that is. So we are doing 9 choose 5, and then divided by 14 choose 5. Okay, that gives us a 9 choose 5, 14 choose 5. Okay, that gives us, is this correct? How come I have a weird number here? 9 choose 5 divided by 14 choose 5. And let me check this. Well, let's move on. Worry about that later. Now, the next thing we need to think about is what if we have 1 dog and the others are non-dogs. To choose 1 dog out of 5, then we have, so 1 dog, I'll write down 1D, 1 dog, then the probability is equal to C of 5 choose 1. Okay, that's choose 1 dog out of 5, and then the rest will be chosen out of, let's see, the rest will be chosen is out of the others, which are 9, and we'll choose 4. So the rest of the toys, the 9 options, we'll choose 4 of them, and this is also divided by C of 14, 5. So when these 2 numbers added together, that should give us the total amount that we're going to be subtracting by 1. And okay, so I just go back. So 9 choose 5 and 14 choose 5 is when there is 0 dogs. Okay, and then let's continue. Plus 5 choose 1 that is, it doesn't matter what that is, because 5 choose 1 times 9 choose 4. 9 choose 4, and then also divided by 14 choose 5. Okay, that should give us, that gives us a, I'm not sure, is this the same? So then, let me check. No, let me see what my calculator is doing. Okay, so I checked the number I got from adding these two probabilities, that is 0 dog plus 1 dog, which equals to this thing. Okay, this looks different than what the book says, but it's the same answer. It's just that the book didn't simplify their fractions. So then, as you can see, then if I minus 1, okay, then that will give me the probability. It's a negative number, but that's because you're supposed to do 1 minus the number instead of this number minus 1. So that gives me a negative value, but it's the same thing. That is, just ignore the negative value, and that is the answer. Okay, and this is the same value as the answer in the book, the 623 over 1001. Because if you do the fraction, then you will notice that they are the same value. I just checked. So anyway, so that is the end of this problem. Now specifically, problem 6 is the most unusual problem. So the example, I mean. So please pay attention to problem 6. Pay extra attention to it and see how things are done. That we're doing when we do this. We have a bunch of stuff when we're choosing among them. Okay, then you have to remember to do the C's on top and each one, and then multiply and then divide it by the total amount of choices on the bottom, and that will give you the answer. So please be sure to do example 6 yourself. Make sure everything makes sense. Okay, and then you'll be able to do the homework. For homework in this section, I lost it. Where's my homework? Is this it? 9.7? Yep, found it. Okay, for homework on this section, please do problems 15, 17, 19, 21, 23, 25, 27, 31, 35, 39, 47, 49, and 57. And when you're done, I want to talk about some of them. So now let's look at homework problem number 19. We're tossing 4 coins. A coin has just 2 sides, okay? And one side is called the head and the other side is called the tail. And 19 says find the probability of tossing 2 heads, and no more, no less. If that is the case, there are 2 heads, so there are 4 options, okay? And so we are going to choose 2 of them to be heads. So then the probability will be C of 4 choose 2, and then divided by the total possibility, which is there are 4 of them, and then we have 2 to the power 4, which is because each coin can be head and tail, so the total number of possibility will be 2 to the power 4, and then the amount then is should be it. So let me get this to come out. So answer would be, let's see, 4 choose 2. Oops. Try again. 4 choose 2, and then divided by 2 to the power 4, which is 16. And so the answer is 3/8, which does check out in the end of the book. Okay, so that is good. And let's move on to the next problem. The next I want to talk about problem, what is it? Let's see, I lost it. 19. Okay, 25. Yep, that's right. So problem 25, we have, now we are going to find the probability of tossing 2 heads, which we already did right now, just now, and also 3 heads. So then 3 heads, we just add the number here. So add the same thing, 4 choose 3. that and divided by the same thing here. Okay, now 4 choose 3 is just 4. And so this is equal to 3/8 plus 4 over 16. That is 2/8. So together is 5/8. And that should be the answer. Yep, it is. So that's so far so good. So next, let's do problem 49, which is identical to example 6, where we have a bunch of stuff and we're going to choose some of them. Okay, we're getting 3 blue M&Ms. To choose 3 blue M&Ms, we have a total of 12. So then it will be C of 12 choose 3. And divided by the total amount of stuff, which is 12 plus 6 plus 10 plus 8 plus 8 plus 4, which is what? Well, let me add that up. And let's see, where's the book here? We have, okay, I will add up on my calculator. 12 plus 6 is 18, plus 10, 28, plus 8, 36, plus then plus 8 again, that's 44. 48, yeah, I got 48. Let's hope that's correct. Okay, so the total is 48. There's 48 stuff, 48 candy, and then and divided by choosing 3. So that is the probability. Okay, so let's do that. Well, I'll just stand on this side. Anyway, so I'm gonna type in 12, choose 3, divided by 48, choose 3. Okay, so that's what I have here, and let's hope that's correct. What is that? Let me check. Well, I got it wrong because I didn't read the problem properly. It says 12 choose 3. 3 isn't all that the guy is choosing. The guy's actually choosing 5. The guy is actually grabbing 5 M&Ms total. Okay, I didn't see that. Yeah, so the total amount of candy being grabbed is actually 5, not 3. I didn't notice that part. So let's fix that. We have 48 choose 5, which means there's 12 choose 3, and also something else choose 2. We need to choose 2. What's the rest of it is not that, so the rest of it will be 48 minus 12, that would be 36. So the rest of it comes from the rest of the candy, and we'll choose 2 of those, and that should make it better. So our problem now becomes, so it's still 12 choose 3. Okay, we need to add to it times 36 choose 2, and then divide by 48 choose 5. All right, so I have changed it into 12 choose 3 times 36 choose 2 divided by 48 choose 5. So that should look better. Whatever that is, and let's see, that doesn't look that good, but it is the correct answer. So that's good. So that's 49. So next, let's do problem 57. Now, if you the question says that there are 317 million total people in the United States, and 40 million are elderly. So what is the percent chance? If you pick 5 random U.S. citizens, what's the chance of one of them being elderly? Okay, so then we're gonna do it exactly the same way. So we have the elderly is we're choosing elderly out of well, anyway, choosing elderly is we need one choose. What was it? 40 million. Okay, so 40 million. M stands for million, which is 6 zeros. Okay, so 40 million elderly, we're going to choose one of them. Okay, 40 million choose 1 times the rest of them will be chosen and we're picking 5 people, so the rest will be picked from the rest of the group, which is 317 million total minus 40 million. That gives it 207, right? 277. Yeah, 277 plus 40 should be 317. Yeah, okay, let's say that it's true. So add the million, which will choose the other 4, okay, and then divided by the whole thing, divided by the total, which is 317 million, choosing 5. All right, so let's type this thing into the calculator and see what it says. Let's see, what do I have right there? Okay, so let me clear out the last problem. And so we have 40 million, for million types in 6 zeros. 1, 2, 3, 4, 5, 6. 40 million, yeah, 40 million, shift C, choose 1 times 277 million, 1, 2, 3, 4, 5, 6. Choose 4, and then divided by 317 million, 317, 1, 2, 3, 4, 5, 6 zeros, choose 5. I hope I typed in all the zeros right. Okay, so the answer is 0.36. So, or in percentage form, that'd be 36.78%. Okay, and that is, according to the book, that is correct. So that marks at the end of this section and the entire book of algebra. So I am completely done with the course, which I'm very pleased about, and I'm very proud of you for finishing it. Okay, and algebra is as a whole, well, at least the stuff that's put in algebra now is somewhat tends to be more tedious than algebra used to be, partly because a lot of the things that in more advanced math, the tedious but somewhat require less difficult concepts to do, are all stuffed in algebra. So that's why you're basically put through the grind. But as you get past algebra and get into more and more advanced math becomes a lot more interesting, and as a whole a lot less tedious. So please consider going beyond algebra if you can. Okay, just because this course might seem tedious in various parts doesn't mean that the rest of math is going to be like that at all. So anyway, we have finished this course, and the next one you should take is trigonometry. And there's also geometry in there, and I haven't figured out exactly when a person should take geometry. I think probably geometry should be taken after pre-algebra, but before algebra. But maybe it's also okay to take geometry right after algebra too. They are not completely related. They are only faintly related stuff that, but the geometry is, to me, geometry is a whole lot more interesting than algebra, because geometry has a lot less grunt work and a lot more interesting puzzles to solve. So please consider taking that, or so please consider taking geometry or trigonometry. Well, either one, if you're going to continue with math, you have to take both. The question is whether you should take geometry next or trigonometry next, or maybe just take whichever one that strikes your interest. Okay, trigonometry is also more interesting than algebra as a whole. So, and then after trigonometry, there's a course called pre-calculus, which is, as far as I can tell, basically algebra and trigonometry combined. Okay, basically the schools make students rehash algebra and trigonometry with a few more advanced concepts. I don't know how many, not that many it seems like. So I will be doing pre-calculus after trigonometry, but only as a summary course, because I won't be repeating the exact words that I that I have done in algebra. So all the stuff in pre-calculus, if it's in algebra, I will skip it. Okay, so the stuff you learn in this book this is it. Okay, I will not be repeating it in a future course. So anyway, I'm very happy that we're done, and I hope that you're interested in taking more math.